We're looking at chapter 3, day 4. We're talking about transformations of graphs. Now, this should be something that you did in algebra class. Hopefully, this is a review, but let's get into it. All right, the first transformation we're going to look at is something called the translation. What you hear me say often is shift. It's kind of the same thing. So if I say translate up or shift up, we're talking about the same concept that we have here. In each of these cases, C is a constant. So if you see that we take a function, and if we add a constant to the end of it or outside the function, we would say that the translation, we are shifting upwards. If we subtract, then we are shifting downwards or translating down. Now, if the constant is inside the function, and we'll review all these in some examples in just a minute. If you see that we're doing adding a C on the inside, well, now we're going to be shifting or translating to the left. If we are subtracting a constant on the inside, then we are shifting or translating to the right. Okay, so those are just some things there, some notes there to add. Hopefully that looks familiar what you've done before. Reflection, if you want to reflect something over the x-axis, this is where you are going to have a negative sign in front of the original function. If you are going to reflect over the y-axis, you see that there is a negative sign on the inside of the function. Again, we'll look at some examples in just a minute. Now, with vertical stretching, vertical compressing, this is where instead of adding or subtracting, we are going to be multiplying. So you can see that there's a C there. If you multiply in front, then you're going to do a vertical stretch as long as the C, that number that you're multiplying by, is greater than 1. If you're multiplying by something and that C value, that constant value, is between 0 and 1, then you're going to do a vertical compression. Okay, so like a half, a third, 1/5, something like that. All right. Now, if you have a negative in front, like a -2, well, that's going to be multiple. That could be like a reflection and a vertical stretch or vertical compression. That's two different transformations in the same problem. Again, we'll look at that in just a minute there. Now, the trickiest one that I believe is when you are multiplying by something on the inside. Okay, so when you have that constant multiplied on the inside, you can see that what I always suggest to do first is to take the reciprocal of that number and then make the decision. Okay, if I take the reciprocal and that number is, the reciprocal came out to be 2. Well, now I know that's going to be a horizontal stretch. Okay, if I took the reciprocal and it came out to be 1/3, then I know it's going to be a horizontal compression. Okay, so that's kind of what I suggest too. I think this is probably the trickiest one because you have to look at that reciprocal concept first before you make that decision, or you can kind of go with what it says on there. If that C in there is between 0 and 1, then you know that's going to be a horizontal stretch. If the C is greater than 1, that's horizontal compression. Again, taking the reciprocal, I think, is the easier way to look at it, or you can have off of those notes. All right. So if we take a look at this example, now we put all those things into one. Okay, so we can see that we have each of these pieces in here, and now we're going to look at all these parts in here together. Okay, so you see how you have A, B, C, and D. All right. Now, as you look on the, if you do on the inside, we typically look at the opposite. All right. So as I was talking earlier, if you're looking at the B value, that, as we said earlier, talks about if you have a horizontal stretch or compression. Again, I like to think about the reciprocal and then kind of go from there. Okay. If you have it on the inside, and again, we're talking about the opposite, we look at the C value being the horizontal translation. If it's shifted to the right or to the left, and we look at the opposite, what it is. So if it's a minus sign, we think typically, all right, that means it's going to go to the right. If it's a plus sign, it's going to go to the left, taking the opposite of what we have in there. Now, as you can see, when it's on the outside, typically we say it's the exact, because if you are multiplying by A, we just take whatever that number is, and we are going to vertically stretch or compress by that number. All right, so that's when you see the A there. All right, that's going to be exactly as you see it, about being exact. If you see the D or some value added or subtracted on the outside, then we're going to say, okay, that is the vertical translation. If it's a +3, we're going to go up 3. positive 3 in that direction, okay? So we're going to take all of these and we're going to go through and kind of look at some examples. And you see there's one more last note for you. When you get to graphing, which we'll talk about later, is that the stretches, compressions, reflections, you deal with those first, then you worry about shifting. Shifting right, left, up, or down is always the last thing, especially the shift up or down. That's always going to be your last thing that you deal with. But we'll get to the graphing in a minute. But if you want to take a look at that part, okay, have that notes because we're going to come back to that in a couple minutes. All right. So what they're asking you to do for this is simply, all I want you to do is to describe the transformation. So if you need to have that top part of the page nearby, so you can have it for access, do that. But this is kind of what we're looking for, is just describe in words. So if I see the -1 on the inside, so the original function was f of x, so I can say, well, when I have a subtraction one on the inside, that deals with the horizontal. And since it's a -1, I'm just going to say this would be to shift to the right one space. Okay, so that means my entire function has just been moved one space to the right. Okay, and that's it. That's all you have to do. If I were to take a nice easy one, if I go vertical right here, all right, if I go the one right below it, and I see the -1 on the outside, well, now we're talking about vertical translations. So all I need to say is that this would shift down 1. Okay, so I'm kind of going vertical with these. I think the little bit the way this is set up, it's a little bit easier to start with this first column here. If I have x plus 1, well, that's on the inside, so I know that this is going to shift to the left one because I'm doing kind of the opposite when it's on the inside like that. And then I see a +1, so I'm going to shift up 1. Okay, so in all those cases that I see there, those are just the basic translations, shifting right, down, left, and up. All right, as you kind of go through, but make sure you realize, and again, the tricky ones is the ones that are on the inside. So be careful with those, okay, as you're going through. All right, so now the next column that we see here is just going to put a couple of these together. So again, as we said earlier, as we were talking about up here, stretches, compressions, reflections are going to go first. So I'm just going to identify those first. So I have this negative that's inside here. What I'm going to go through is I'm just going to say, well, that's just to reflect over. And when it's on the inside, hopefully you remember, or you can look up above, reflect over the y-axis. Okay, so that's the first part. The second part then, I'll change the color real quick. If I see this +1, just like we talked about on the left-hand column, I am going to just shift up 1. Okay, so basically I just had two transformations in this one. The first one reflected over the y-axis, the second with the negative on the inside. The +1 tells me that I'm just going to shift up 1. All right, so now go back to here, and if I see the negative on the outside, this one is telling me that I want to reflect over the x-axis. That's the negative right there is telling me. Then if I want to go through and look at the -1 that I see, well, as we talked already, that means I'm just going to shift that entire function down 1. Okay. So we tried the next example that we see here. The minus sign right there, again, is telling me to reflect over the x-axis. And then I see the plus sign in there is telling me that I want to shift to the left one, okay, because the plus sign that I have inside there, all right? And then if I go to the last one in this column here, go back to purple to get the reflection part first, we see that we are going to reflect over, oops, that didn't look so good. Try that again. All right, I want to reflect over the x-axis. And then again, we'll do the green for the second part here, that +1. I am going to shift up 1. Okay, so there's that second column. All right, if you want to take a break here and try the third column on your own, you're more than welcome to. If you want to pause it right here. Otherwise, I'm going to get into it right now. So you want to pause and try yourself, go ahead and then come back and check. You go ahead and be my guest, but we're going to go through this one right now. All right, now here's the tricky one. This first one in here, because the big inclination is to say, well, this 1 minus x, to do the transformation with that, it's not easy to do as you see it right here. What you actually have to do with this is rewrite it as negative x plus 1. That's the first part that you have to do. Now, even the way that it is, we cannot use our rules from above in order to answer this question. Instead, what we have to do, this is the trickiest one right here, so if you try it on your own, let's see how you do right this, is that I have to actually factor out the negative to make it a positive x on the inside. And because I'm factoring it out, I need to make this a minus 1. So this whole part right here became this. And then when I factor out that negative, I have this, right? So you can kind of see that part in there. And now when I make my decision, this is what I'm going to go off of. F of negative x minus 1. That's a tricky one. This is probably one of the hardest ones that I think I saw on this page. Okay, so now when I look at this, is I actually have 3 transformations in doing this problem. The first transformation, well, that's that negative that's right inside there. So the first thing I'm going to say here is that we are going to reflect over the y-axis. Okay, the second transformation, now we'll go to purple here. So I'm going to go to the second transformation. Well, that's this minus 1 on the inside. So what I can say is that we are going to shift to the right 1. And then the last one I'm going to do is I'm going to do this plus 1 that's on the outside here. And this one, and run out of room over here. So hopefully you give yourself enough room. And I'm going to say that I'm going to shift up 1. Okay, so that is how you have to deal with one. So that was probably the hardest one with that whole 1 minus x on the inside. I have to rewrite it as negative x plus 1, factor out the negative, so then I can see that there's the reflection portion, and then I still have to go to the right, and I still have to go up. Okay, so that one's a tricky one. So if you did a good job on that one, congratulations, but I will say that one's a tricky one that you're looking at. All right. Now, if we go to the next example here, hopefully, again, you tried this one on your own. You got a couple things going on. If I look at this one inside here and just start with this, I'm going to say that this is going to reflect over the x-axis. And then if I go to this inside here, this one that I can right there, this one is a reflection over the y-axis. And then again, I have that last one that we can see right there, the plus 1, kind of run out of room right here again. I'm going to say this is to shift up 1. All right, kind of run out of room over here. These kind of, I guess I should have given myself some more space. We're going to kind of space this out right there. Okay, so now if we take a look at the next one only has 2 transformations. Okay, so our first one that we can see here, if we look at the plus 1 that we have on the inside, right, we've been talking about that already. And actually, what I'm actually going to do is look at this 2. Now remember, if it's multiplied in front, you keep it exactly the way you see that. So the 2 multiplied in front is telling me that I have a, I'm going to abbreviate here, a vertical stretch by 2. That just means instead of going, you know, up by 1, 2, 3, 4, I'm going to double each of those numbers. So my y values are going to get doubled, 2, 4, 6, 8 kind of concept that we have there. All right. So that's going to be a vertical stretch by 2. And then we've already talked about this where you have the minus 1 on the inside. We know that the second thing that we have is going to be, oops, not an R. We're going to say that we want to shift to the right 1. Okay, so there we have that shifting part. All right, now if we take a look at the next one, this is where things get really tricky, is that when you see that 2x on the inside, what I always suggest do first is take the reciprocal. Hopefully you recognize the reciprocal of 2 is 1/2. Well, what do you know about 1/2? Well, 1/2 is less than 1. So what that means is that it's horizontal because it's on the inside, but because it's less than 1 and greater than 0, we know that it's a horizontal compression by 1/2. That means your x's are going to get cut in half as you're going through and looking at those problems, okay? And again, we'll get the graphing on the back side. All right, so that's always the trickiest one, okay? When you see that number in there, take the reciprocal first before you make that decision. All right, and then obviously this minus 1 down here, we know that this means just to shift down 1. Okay, so that first one, we started that last column. That first one was probably the hardest one. But again, I think that last one, there's where students have the most difficulty, is realizing that when you have that inside number multiplied, take the reciprocal first, identify that 1/2 is less than 1. So you know it's a horizontal compression because that is the reciprocal is less than 1. All right. So there's the front side with just some basic describing what's going on. Let's take a look at some graphing. Okay, so let's look at the back side that we have here. Our job is to graph the following functions without using a calculator. So again, identifying your transformations is what's going to make the difference here. So if I look here, there's 3 transformations. Hopefully you recognize these. Okay, so we got transformation 1, transformation 2, transformation 3. So number 1, if you want to pause right here and try yourself and then come back, go ahead. Otherwise you can follow along with me. If I take a look at the minus sign in front there, I know this means that we want to reflect over the x-axis. Number 2 tells me that we are going to shift left 2. And then number 3 tells us we are going to shift down 2. So now if you know the normal, we talked, earlier in the week, we talked about, well, these graphs, this g of x, the basic f of x is just equal to x squared. That's just that nice quadratic that we have there, right? That usually starts at 0. The vertex is at 0, 0, and then it just goes up by 1, 3, 5 pattern to the left and to the right and makes a nice parabola in there. Well, now we're going to do this. So instead of starting it, we're going to start at 0, 0 still. And now what happens is it's going to reflect over the x-axis. So when it starts at 0, 0, that has no impact on the norm or that location of that coordinate. What it does, though, instead of having our normal graph go up and down, or sorry, go upwards, it's going to be going downwards because we're going to reflect over the x-axis. Okay, so it's going to go downward instead. Also, what's going to happen is we're going to be shifting to the left 2 and to the down 2 and down 2. So instead of being at 0, 0, we're now going to be at negative 2, negative 2. That is where our vertex is going to be. Now we know that our normal parabola goes up 1, up 3, up 5. It has that pattern as you go work your way to the side. We're going to do the exact same thing, except instead of going up 1 over 1, we're going to go to the right and down 1. So we have there and we have there. And then instead of going 1, now it goes 3. So 1, 2, 3, and over. I'm going to go 1, 2, 3, and over there. And so you're still keeping your axis of symmetry, if you remember that from the parabolas, but now it's going to be going downward instead of upward, and it got shifted, and hopefully you draw it better than I did. And there's your parabola that got shifted and transformed from the original x squared graph. All right. So if I take a look at my next example, we'll do a different color here to try and keep these separate from each other. If we look at the first part here, right, this is going to be a vertical stretch by 2. We'll talk about that in just a minute. And then the next part that we have here, well, again, that's just going to be shift to the right 1. So we got 1 and we got 2. Okay, so as we said before, the typical graph is that we would say, all right, we're going to start here at 0, 0. If I vertically stretch it by 2, okay, so vertically stretch by 2, we're still going to say 0, 0, but now it got shifted to the right 1. So now I'm going to be over here at 1, 0. Now, the next coordinate, right, so we were at 0, 0, and all that happened to that is it went 1 to the right because the vertical stretching by 2 had no impact on the y because 0 times 2 is still 0. The next coordinate we know is 1, 1 on the normal quadratic. So if we stretch that by 2, that means that that 1 for the y value is now going to get doubled. So now instead of being at 1, it's now going to be twice as big. Since it was at 1 and it moved to the right 1, it's now also going to be at 2. So instead of being at 1, 1, that coordinate moved to 2, 2. And because the nice part that we have there with the symmetry, I know this is going to be 0, 2 as well. We'll do one more. Now, if you remember, it's usually at 2, 4. That's the next typical graph that we have there for x squared. Because it's getting, the y value is getting doubled, that is now going to go to 8. Instead of being at 2, that moves the right 1, so we're going to add 1 there and say it's at 3, 8. So with 3 And there is 3, 8. And again, because of the symmetry, we're going to be at negative 1, 8. And there is going to be my new parabola. So all it was see how it got vertically stretched, right? Instead of the basic one is vertically stretched. The y value is twice as big as it was before, okay? Now, if we take a look at the next group, all right, again, we'll do a different color here, make it a little more exciting. All right, so we have this negative on the inside here. Hopefully, again, if you want to pause and try your own, go ahead. If you look at the negative that we see there, we know that this is going to be reflected over the y-axis this time, okay? If you look at number 2, right, the second transformation, we know that's going to be up 1. We're going to shift it up 1. So hopefully you remember that the normal graph, if we were to look at the basic one, we know that it is the square root of x. That's the parent function that it came from. And hopefully you remember that starts at 0, 0 and works its way that way. Okay? Well, now instead of being reflected, instead of going towards the right, is that now it's going to be reflected. So reflecting on the y-axis is now going to make it go towards the left. Okay, but then we also have to do up 1. So we typically would start at 0, 0, but what's going to happen is instead of, we're going to go to 0, 1, and a reflection on the y-axis is not going to have any impact. So we're going to leave it at 0, 1. Okay, so now instead of being at 1, 1, if that reflected over the y-axis, that would go to negative 1, 1, but also could shift up 1. So we're going to get that as the new coordinate. And I'll get rid of these two guys, so you don't confuse you. Now, the next one, remember square root graph. So we were at 0, 0, and that now went to, oops, I think I got lost in there. There we go. That went to 0, 1. It was at 1, 1 because the reflection and the shift up, it's now going to be at negative 1, 2. If you remember, the next part of the graph that's on there is 4, 2, the next integers that we can look at. So 4, 2. So instead of being at 4, 2, which would be over here, is that now that's going to be reflected. So that's going to go instead to the left-hand side into quadrant 2. And that's going to instead result at negative 4. And instead of being at 2, shifting up 1 makes it at 3. So I have negative 4. I'm going to go up to 3. If you remember that you can think of one more, we'd say we would be at 9, 3, right? Somewhere over here. But that one's going to instead reflect. So go to negative 9, 3, up 1. So if you want to make a nice graph so you can see it. And I'm going to go to the right over there. Okay, we'll get rid of these guys so don't confuse you. All right, so far that's what we're looking at. Okay, hopefully things are going well. And if you just click back in and check your answers, hopefully you're doing all right. Last one we're going to take a look at, what haven't we used yet? Let's try a little red there. Okay, so if you look at our transformations, the first transformation that we have here, we know that this is going to reflect over the x-axis. Okay, so think about how that impacts it. The second thing that we have there is we are going to go, oops, actually we'll squeeze it over here. For number 2, we are going to go left 1. All right, so let's take a look. Again, we're using the exact same graph that we had over here, right? This is the same thing that we're going to use, but now we're going to put it over into this other example that we have. So if I start at 0, 0, if I were to reflect over the x-axis, has no impact because it's on the x-axis. If I go left 1, well, now I'm going to be at negative 1, 0. Sometimes it does help to write it out first. And, if you're getting stuck with this, not quite sure, maybe write it out and see what happens. We already said that we were at 1, 1. If I reflect, remember doing those reflections first. If I reflect over the x-axis, well, instead of being at 1, 1, which is right over here, reflecting is now going to make it down into the 4th quadrant. So instead, reflecting over there is going to make it 1, negative 1. But then I also got to go to the left. So I'm going to go end up being right there. So we would say, okay, well, actually now we're going to be at 0, negative 1. Okay, so that's what's happening there. All right. All right, we'll take a look at a couple more. So we were at 4, 2. If I were to reflect over the x-axis, so 4, I'll get rid of this guy right now. If I look here at 4, 2, it would be right here. If I reflect it, it's now going to be underneath and go down to 4, negative 2. But again, I got to move it one spot to the right. So now that's going to be at 3, -2. I'm going to be right there at 3, -2. I'll get rid of this guy. Put in there at 3, -2. And we can look at one more again, as we talked about 9, 3 being there. Well, if we look at it, instead of being 9, 3, it's going to be 9, -3. Move it one over, we're going to be at 8, -3. And again, it will keep going to the right as we go there. All right. So hopefully you get a chance to look at these transformations. Hopefully they are familiar to you. First part is writing them out. Second part, if you need to, is to write out and then graph. All right. So make sure you look at the directions carefully. As you can see on the bottom there, you got a fun activity for you, Desmos marble slides. See how you can manipulate the graphs using your transformations, using the front part of your paper if necessary, to see if you can get all the marbles into one spot. It's actually a fun game. So go ahead and try that out. Okay. If you got questions on day 4, please ask your teacher. Bye.